Alright, so what I'm going to do now is show you how to carry out a chi-square test the easy way in Excel. Let's back up a little bit though, and let's go back to what we were working on in the PowerPoint that shows you how to calculate chi-square values. So, what do we have here? We have monarch butterflies. They're flying down to their roost site or their overwintering site in southern Mexico, and we have an observation. The observation is that the male butterflies roost more frequently at higher points on the roost trees or the oyamel trees, and the females roost more frequently on the lower branches. This is an observation made by an ecologist. And what the ecologist does is she gathers some enumeration data. So she does some counts. At areas of the tree above 5 meters or on branches above 5 meters, she finds 380 females to 480 males when she counts the bugs that are up there. And below 5 meters, 623 females, 370 males. Now, obviously, it looks like her observation is backed up by the data, but she has to test it. How does she do this? Oh, well, she has to use a chi-square test. So is there a statistically significant difference in the choice of the height of overwintering roosts of male versus female monarchs? And we have our data. Now, we did this. We calculated the expected numbers, and we calculated our chi-square value. In this case, we used a traditional chi-square table, and we calculated our chi-square value. Our chi-square value was well above the critical value from the critical value table. Again, we had 1 degree of freedom, and we rejected the null hypothesis. In this case, we saw that the data suggests strongly. Well, it says that we reject the null hypothesis and that there is a significant difference between the two roost sites. Females tend to prefer the lower branches, males tend to prefer the upper branches. Great. Now, what did I want to do? Let's go back and we're going to take a look at our table here. So basically, I'm going to take this table, the observed numbers above 5 meters, expected numbers above 5 meters, observed and expected values below are expected frequencies, and I'm basically going to take this table and put it into Excel. Oh, look, I've already done it. Here it is. Here's that same table cleaned up a little bit or removed some of the color, but we have our observed values and our expected values for roost sites above 5 meters, observed, expected for roost sites below 5 meters, and we have our male and female columns. And now we want to run a chi-square test. So let's do that. Now, in order to do this, well, first off, let's pull up the formula builder. Great, put it over here. Type in chi-square. Very good. Click. Okay. Now, we want to select where we want it to go. Close. Get away. Oh no, we're messing up here. Delete. All right, good. Now, let's go to where we want the chi-square value placed. Right there. Fine, good. But there is one problem. All right, we have this original table that fit the way that we did our traditional chi-square table well, because you can calculate by hand the individual values that sum up to the chi-square easily using this table where we have the two different categories: roost site above, roost site below 5 meters, male and female here, observed, expected. This type of layout worked well for doing it by hand, but in Excel we need to actually change the layout. We need to lump the observed values together, all right, in a block or in an area of an Excel table. And then we need to lump the expected values. So you can see here, it's really small, but what we need to do is take the female value, all right, there we go, the male value, move this down, okay? And now we need to take the observed numbers below 5 meters and move them in here. In other words, we're putting all the observed numbers together. And now we need to put all of the expected numbers together, male and female. So there we go. And doom. Doom. Okay, great. So we just basically reoriented things here. You can see it's a small alteration. Here we go. White, green, white, green. Now we've got all the observed white values together, all the expected green values together. The totals should still be the same they are. So 860. What's coming up red? Who cares? We really don't need to do this, so why don't I just delete 860? You know what the totals are. Now let's carry out the chi-square. So find the space where you want the chi-square value to go and click on your formula builder. And in this case, again, type in chi-square-test, double click on it. Up will come this window down here. Now it says actual range. And again, just like the other podcast I was telling you, actual is synonymous with observed, and what we need to do is find the range of the observed value. So we take this whole white block here, observed female above 5 meters, observed male above 5 meters, observed female below 5 meters, observed male below 5 meters. And then, great, we've done that. Now we need to select the expected range, and that's just simply these 4 blocks here. Take those together, all right, and then you hit enter, and there's our number. Now look at this. What this is an extremely small number, all right? Our chi-square value, keeping in mind here in Excel, chi-square values are p-values. This number is well below the 0.05 critical p-value. In this case, we reject the null hypothesis, and we can state with confidence that there is a significant difference in the frequencies of males versus female monarch butterflies roosting at the high portions of the trees versus low. It looks here, this strongly suggests that females prefer to roost at lower sites or lower branches on the tree. All right, so you can see chi-square tests, they can be a bit confusing when you're tabulating them by hand, but in Excel, which you're allowed to use for your reports and so on, it simplifies it immensely. All right, thank you.